This is the Unit 9 review. First set of problems, write each expression in radical form. So when we have a negative exponent, this means to take the reciprocal of the base. So this is 1 over x to the 3/2 power. And it's really 1 over x to the 3/2 power, but 1 to any power doesn't matter what it is, it's always going to be 1, so we can just write it as x to the 3/2 power. So now in radical form, what would that be? That would be 1 over the square root of x to the 3rd power. This next one, radical form, this is the square root, right? Because there's a 2 of 5k taken to the 3rd power. Now you don't need that 2 in there, so it's just the square root, but there's an invisible 2 there. Next couple problems, write it in exponential form. So exponential form, this is m to the 1/2 power. Remember, if we want to change from radical form, let's say we had x to the 3/2 power, that in exponential form, let's say 4/3 power. So that's exponential form. Now in radical form, that means the 3rd root of x taken to the 4th power. Okay, so track where this stuff goes. Our numerator is our power and our denominator is our root. Same thing here, this is 1 over 4n is in our denominator, right? And so how do we get that under 1? Well, we must have had a negative 4/3 power, so this is 4n to the negative 4/3 power. Simplify this. So we want to take, so this is 1 over the square root of 81p squared. So this is 1 over 9p. We need to distribute this. So this is the cubed root of 64. Right? Taken to the 4th power. And r to the 6th, right? 6 times 4/3, well, that makes 2. 2 times 4 is 8. So that's times r to the 8th power. So the cubed root of 64, well, what is that? 4. 4 times 4 is 16 times, so 4r to the 8th. 6. Problem 7. 3 times 4 makes 12, r squared and r to the 3/4, so we need to add, right? 2 plus 3/4, well, 2 is how many fourths? That's 8/4, right? So 8/4 plus 3/4 makes 11/4. So this is 12r to the 11/4 power. Next one, this is b to the 1st, right? Or b to the, how many is 1? That's 4/4, right? So this is 4 times 1, which makes 4. And 5/4 plus 4/4 makes 9/4. Same thing here, we're simplifying, so we just need to multiply, right? Power of a power, base to a power, and it's to a power, so 3 times 3 makes 9, 4 times 2 makes 8. Same thing here, this is negative 2 over 1, so this is v to the negative 4 over 3, so this is 1 over v to the 4/3 power. With no fractional exponents in the denominator. So that would mean if we don't want a fractional exponent in the denominator, then I'm going to make it like that, negative 4/3. This would be our answer. Uh, 11 and 12, we're doing the same thing. We're going to subtract So we know that this is, we need to subtract these exponents. So I've got negative 2/3 minus 1/3. So what's that make? Negative 3/3. So this is x to the negative 1. So this is 1 over 3 and x to the negative first power, which means to take the reciprocal of the base, so it just puts our x on the bottom. Our next one, same thing here. We're subtracting, so this is n to the 5th over 3. (13) square root of 20 is the square root of 4, square root of 5, so that's 2 root 5. 216, ooh, square root of 216, uh-oh. So that's square root of 36, square root of 6, square root of 36 is 6, so that's 6 root 6. The cubed root of 32 is going to be, well, I know the cubed root of 16, right? 2 times 2 times 2, that makes 4. Oh, that makes 8. Never mind. So how about 4 times 4 times 4 is 64. So what other cube root? Oh, 8, right? So we could say that's the cubed root of 8 times the cubed root of 4, right? Because 8 times 4 makes 32. And what's the cube root of 8 is 2. So that's 2 times the cubed root, times the cubed root of 4. So the 5th root, well, I know the 5th root of 32 is 2, so, and 32 times 5 is 160, so the 5th root of 32 is 2, so that's 2 times the 5th root of 5. Skip, don't you? Alright. So our next set, the cubed root of 64, so that's 4. Cubed root of x squared I can't take, right? And the cubed root of y to the 8th, well, 3 goes into 8 twice, so that's y squared with how many left over? 2 left over. Same thing here, 294. Well, 294 would be the square root of 49 times the square root of 6, square root of x squared, square root of y to the 4th. So square root of 49 is 7. Can't do the square root of 6. Square root of x squared is x. Square root of y to the 4th is y squared. What do we have inside of here? Square root of 6. Negative 5, square root of 9, square root of 2, and square root of 9 is 3. Negative 5 times 3 is negative 15, square root of 2. Square root of 64 is 8, so 5 times 8 makes 40. (21) In order to add and subtract, they need to be the same base to the same power. So, right, these are 3 to the, what, 1/3 power? That's the cubed root, right? So 3 to the 1/3 power. So what am I going to do? I'm going to add those. So what's negative 3 and 3? That is, makes 0. So I'm left with 3 times the cubed root of 5. 22, I need to simplify first. This is negative 3, square root of 9, square root of 5, because 9 times 5 makes 45, plus 2, square root of 4, square root of 5, because 4 times 5 makes 20. Minus 3 square root of 2, well, this is a 3, so that's negative 3 times 3 makes negative 9 square root of 5, plus 2 times 2, because that makes 2, so 4 square root of 5, minus 3 root 2, well, negative 9 and 4 make negative 5 square root of 5, minus 3 square root of 2. Similar problem here, 5 square root of 5 over 4 square root of 9 square root of 5. What can I do? I can simplify it to 1, so this is 5 over 4 times 3 makes 12. Same thing here, square root of 15. 3 and 5. I don't think I have anything, but we'll see if we can simplify it later. Square root of 48. So that's square root of 15. We'll figure out, once we do 48. 48 is what? 16 and 3. Square root of 16, square root of 3. So I'm going to say the square root of 15, instead of the 15, I'm going to say that's the square root of 5, square root of 3, right? Because 5 times 3 makes 15. Now I can get rid of those 3's. So this is the square root of 5 over, what's square root of 16 over 4? 25, square root of 8, so this is 4, square root of 4, square root of 2, over square root of 9, square root of 2. Well, what happens? The square roots of 2 go away. Square root of 4 is 2, so 4 times 2 is 8, and square root of 9 is 3, so that's 8/3. 26, solve by taking the square roots. Square root, x equals plus n minus 10. Subtract 6, 4x squared equals negative 10. Divide by 4. X squared equals negative 5 halves. Take the square root, and x equals plus n minus I times the square root of 5 halves to make out that negative 1, right? Next one. What problem is that? 27, so we're looking at 28 here. 28 solved by completing the square. Problems are different. Your problems are different. So this is square root of negative 28. Right, so this is what goes into 28. Would be, does 4 go in? No. Does 9 go in? No. Oh, 7 and 4. Alright, so this is negative 1, square root of negative 1, square root of 4, square root of 7, right? So what is this negative? Square root of negative 1 is I. Square root of 4 is 2, and square root of 7 we can't simplify, so this makes 2i square root of 7. Our next one, square root of negative 9 over 16. Well, that's the same as the square root of negative 9 over the square root of 16, which is I, or, square root of negative 1, square root of 9 over, what's square root of 16? 4. Right, so from here, we'd say, well, what's square root of 1 is I, so that's I times 3, or we'd write it actually as 3I over 4. 29, 25x squared plus 16 equals 0. Subtract 16, 25x squared equals negative 16. Divide by 25. So x squared equals negative 16 over 25. Take the square root of both sides, so that's x equals plus n minus, this would be 4i over 5. B would be x squared plus 9 equals 45, so subtract 9. X squared equals, what's that, 36, take the square root, x equals plus n minus 6. Let's do some more here. So problem 30 says x squared plus y squared equals r squared, and we want to solve this for x. So subtract y squared, and we get x squared equals r squared minus y squared, and take the square root. So x equals plus n minus the square root of r squared minus y squared. And we can't Well, we can. This is actually x equals plus n minus. No, let's leave it like that. V is f equals k mv squared over r, and we want to solve this for v. So what's happening? We need to multiply everything by r. So rf equals k mv squared, divide by km, divide by km, and v squared equals rf divided by km. And what are we going to do? We're going to take the square root. So we get plus n minus the square root of rf over kma. There we go. Lost my spot. Here we go. Over the square root of km. Km. And that's what v equals. And the last one, a equals 4pr squared, and we want to solve that for r too. So divide by 4p. So r squared equals a over 4p. Take the square root. So r equals plus n minus the square root of a over 4p.